Anyway, thanks everybody for being here. My name is Alan Ranciato. I am a cloud engineer at Google. Little background about me. I joined Google about 10 months ago. I come from industry, so I've worked over the last 10-ish years on some pretty large enterprises focused on transformation. So DevOps is a little bit where I've lived for a while. Working on agile transformations, legacy businesses, modernizing applications, really trying to change the world, make things better, make things a little bit more fun. So I'm going to talk to you a little bit about my experiences, talk to you about DevOps, what we do here at Google, as well as some of our tools. But I'm trying to focus away from the tools a little bit and just more about conceptual, what DevOps is, and we'll go over some of the things that we have to help you get there. So agenda today, what is DevOps? Just a little intro on what we're trying to do. Infrastructure as code, continuous integration, delivery, CI/CD, buzzwords, and serverless computing. And I'm not really going to cover serverless computing because I know we've talked about it earlier and there's going to be a pretty big presentation about it coming up, I think, right after me. So if anybody has any questions, there is a link at the top of the slides. Feel free to throw it in there. I can see those while I talk versus in the Zoom, so that might be helpful. And we can cover it as we go or at the end of my presentation. So DevOps. So in general, in business, incentives are not aligned. So developers are focused on putting out product, putting out new features, focusing on the customer, whereas operators are about stability. So in any organization you get in, developers want to move fast. They want to move things along. They want to release code. They want to change services. They want to get new access to their applications. They want firewall rules. They want all of that. Operations usually says no. Operations says submit a ticket. Operations says we will have somebody do that and we will do it manually because that's how we've always done it. And that's really where DevOps comes into play. It's really a relationship between development and operations. So if you go to Google and you type DevOps there are a lot of different opinions. You're going to see DevOps is dead, DevOps is a culture, is not a role, is not a team. One of my favorites is hearing we do DevOps or we do the DevOps. It's become a buzzword and it's become just something people want to do but don't really understand what it is. A definition, I'm not going to say it's the definition, but a definition of DevOps is an organizational and cultural movement. So it's not a team, it's not a group that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. Really what it does is it works on communication and it automates processes, which allows us to push out services and systems fast and a lot more reliable. And in the end, gives us happy users, happy customers, internal auditors, and really checks all the boxes for what we're trying to do. So time to market is one of the huge benefits. So as ideas come about, you get features, you get bug fixes, enhancements to things, and it's really just an iterative approach. So it's a way of thinking versus a big bang. Everybody talks about boiling the ocean. It's not something you're trying to do. It's not a start a 6-month project and we start to release software after 6 months. It's really just a how do we get things out faster, but make sure we're doing it in a safe way, bringing feedback to our developers and being able to make changes and being agile. So, you will often see DevOps come along with agile when you go into transformations of large enterprises. Key differences between traditional IT and DevOps delivery models. So in traditional IT, you look at the impact that projects have. Success metrics on a project is usually cost. In a DevOps model, it is business KPIs, so key performance indicators. What success are we actually seeing from it? Not looking at the overall cost to deliver, but what's the ROI? The speed in traditional IT, month and years. Here in a DevOps model, you're talking days, weeks, and months at the most to actually deliver things. And you're going to deliver pieces of things. You're going to do things differently. You're going to develop things differently. You're going to slowly iterate. You're going to use feature toggles. You're going to use different things. Organization and funding. Things are project-based versus things being product-based. What that means is you're not spinning up a project plan that just says this is our end-to-end. From a product base, these are the features. When you start going into Scrum, when you start going into Agile, when you start going into the different methodologies that are used to deliver software, deliver products, you're really looking at what are the features. You're breaking it down to the small little pieces, and that's what you're trying to deliver. New ways of working is another piece of it, and that's matrix and silos would be our traditional. In the DevOps model, it's autonomous and self-contained. So teams are autonomous within each other. There's the term of two pizza box, and that says, a team should be no larger than it takes two pizzas to feed the team. And that's really the team that's developing your software and that is developing your features. And it's not just software developers. That team may have a project manager, a scrum master. That team may have developers. That team may have operations people. That team may have QA. All of that together, and that is really an autonomous team that's able to deliver value to your organization. Releases go from a high-risk event to a non-event. I've worked in organizations where, and I'm sure we all have, where you go in at 2 a.m, everybody brings donuts, everybody is there, and the next day at 10 a.m., 12 p.m., 1 p.m., you're trying to figure out how to roll back. Everybody is working on fumes. Everybody is dying at this point. And you don't know what went wrong. And then you try it again 2 days later. Releases with the DevOps model should be non-events. It should happen automatically. It should happen in the middle of a Tuesday afternoon, which is perfect because everybody's awake, everybody's on site, something goes wrong, it's easily recoverable. You don't have to suffer and you don't have burnout on your teams. Goes from application sizes of large to micro MVPs, microservices, pieces of the applications go out individually. And then technology, it's automation. It's all about automation. Manual human intervention in the traditional IT model versus automation of my software delivery, infrastructure as code, IAC, you'll see that a few times throughout this presentation. Architecture tightly coupled, the monolithic applications versus loosely coupled. Let's just push out APIs. Let's version our applications. And then infrastructure, data center versus cloud. Do I want to be in the business of managing servers? I really don't. I want somebody else to do it for me. I want Google, I want Amazon, I want Microsoft. I want somebody to manage all of my infrastructure for me so I can focus on what really is making my company money. And then, the optimizing the flow of work, and I won't go through all of these just because you guys can read this yourselves there. But, just from a planning, development, and test, release, and deploy, and monitor, and optimize, and think of that as just a large feedback circle. It's being able to say, I want this feature. How do I develop it? Let me get my developers out there. Let me release it. Let me monitor and optimize it and provide that feedback back to the planning side. And being able to actually release the next feature or iterate on that and make it better. So it's continuous planning, it's test automation, it's automating the release, not waiting on ServiceNow tickets to be submitted and manually approved, and really seeing metrics and reliability out of everything you're doing. So we want the metrics, we want reliability, we want to see how things are performing, and we want to be monitoring that and improving on that the entire time. And, I've always said, data and metrics without action is just noise. So you don't want to be logging everything. You don't want to be logging, your performance if you're not doing anything about it. You want to see how these services and these things you're releasing and your infrastructure is actually doing and what it's doing, and then being able to iterate on that and actually improve that as you go. Here's a little quote about site reliability engineering, SRE. It's how Google breaks down the wall between developers and operators. and it's how Google runs production systems. SRE is a result of asking the software engineer to design an operations function. What that means is we're no longer in the business of building virtual machines by hand, of configuring firewalls by hand, of clicking buttons. Everything should be provisioned via code. Everything goes through, from an operations perspective, the same process as software development and building an application does. And by doing that, you really bring those software development processes and the repeatability aspect of it to your operations function. And then you technically have DevOps. It's a development function of operations. SRE best practices at Google. So redefine reliability. And that's really determine what are your reliability numbers for everything you're releasing and everything you're doing. Make sure that your reliability numbers are correct and that you're looking at the right service level indicators, that you are determining what level of reliability you actually need. There's a cost to adding more nines of reliability to an application into a system. You want to make sure that you're not over-engineering because you'll never be perfect. You want to make sure that you're looking at your systems you're releasing and you are providing that right level of reliability. Reducing toil wherever possible. So if you are continuously fixing the same thing, if you're continuously restarting app pools, if you're in that world, if you are continuously fixing firewall rules, or if you're continuously doing certain things when applications go down, you need to fix that. And that's one of those things where it's a burnout aspect, it's a waste of time effort. But also determine, what is the cost to automate it to? Is it something that is going to happen once or twice and it's not worth the automation, or is it something that I can really focus on that is going to save me and then I can focus on something else next? Balancing speed versus risk. And that's, you see the word error budgets there. And that's determining, what level of errors you can actually assume and what is okay with breaking. There is a certain level that is okay. And taking the emotion out of that and determining what level of risk versus I need to fix that, or I can focus on the next feature I need to roll out. And then making small changes. You want to make sure everything can be rolled back, everything is incremental, it's not a big monolith as you're releasing things. Things that can move forward, things that can move backwards. You're not going to release a whole bunch of breaking changes to a lot of users. You're versioning your application, and then really creating the right culture. Things will break. How are you going to react to it? And that's the question of how do we do it in a blameless society? How do we manage everything we're doing without pointing fingers and saying whose fault is it versus how do we fix it? And that's where we need to focus. Too many organizations that I've been in personally have gone through the process of figuring out who broke it versus what's actually wrong and how do we fix it, and then focusing on how do we fix it so it doesn't happen again. Let's make sure we focus on that. That's the real problem. Things aren't. It shouldn't ever be somebody's fault. It should be how do we make sure we don't have it again. Infrastructure is code. Cattle versus pets. And this is something you'll hear a lot. I know there's a meat shortage right now, so the cow thing is probably not necessarily the best topic. But on cattle versus pets, we want to make sure we treat all of our infrastructure as cattle, not as pets. We don't care that this machine's been running for 365 days and hasn't gone down. We don't care that, I need to make configuration changes and I want to do it individually, machine by machine, or SSH into a machine to make a change or change a log configuration. I want to be able to not treat all of my infrastructure as cattle, or as pets, but treat it as cattle, whereas I can automate it. If it disappears, it disappears. Another one will spin up. I don't care where things are. Things are managed for me. The benefits of that are code management. commit, version, trace, collaborate, just like source code. So all of my infrastructure should be treated just like source code. Declarative. I don't care how it works, or let me rephrase that. I don't care how it spins up and starts running. All I know is I want a certain amount of machines of a certain spec. I don't want to say I need to start these. I don't want to say I need to configure these a certain way. That should all be done in the code management aspect of what I'm doing. Auditability, different infrastructure between desired state and current state. I should always know if there is any sort of drift in my configuration, and I should be able to fix that automatically. And then portability, being able to reuse modules across an organization. I don't want to have to redo things. An automation pipeline is where we want there. So modules, configuration, all go into planning, deploying, and promoting. It is CI/CD, it is continuous integration for automation and for infrastructure. And then we start getting into solutions. So here at Google, we have a product called Deployment Manager. The Deployment Manager is a workflow management infrastructure configuration platform that allows us to configure the GCP platform. It allows us to spin up virtual machines, build networks, create access, firewalls, create databases, basically set up our configuration, roll back our configuration, and reuse that configuration. It's based on YAML, but we do have templates, either Jinja2 or Python, and customization is a part of that. It is a declarative configuration language. So, it is based in YAML, and the whole point of the declarative configuration language, as I mentioned earlier, is that you just tell it what you want. You don't tell it how to do it. So as things do start to move, as things become spin up, spin down, you don't have to care. You just say, this is what I want. These are the number of machines I need to run this workload. Auto scale it, do what I need to do, and it's going to do that without having to constantly monitor and constantly say, okay, well, now I need to change the template to say I need X number of machines and they need to be tweaked like this. So the deployment manager does work through the underlying APIs. It works with the gcloud API, and it saves deployments, and you can roll back, and you can use it for click to deploy and marketplace solutions as well. So if anybody's used Google Cloud, you can go into the marketplace and click on, say, something like Spinnaker and say launch in GKE. And it uses Deployment Manager to actually build you a GKE cluster, to launch the application, and to do all of that. And that's basically Deployment Manager behind the scenes. Some examples of syntax in Deployment Manager. We create resources, and those resources have a couple different properties. So there's the name of a resource. There's types. Types within Deployment Manager are either base types, which are, say, network, or a compute instance, a VM, or a GKE cluster, or they are templates. And templates are basically saying, I need this cluster of different things, and I can build a machine as a template, and I can build a specific configuration, and then I can launch that resource for reuse later. So those can be composite types or templates. And then properties, and that's where you would set your zones, your machine types, what networks, and actually link back to other configuration that you're doing. So it's parameterized, and then this is an example of how we set that up. So, you have imports, and you can tell it what to import. So I told you it was Python and Jinja templates to be able to templatize your YAML files. The resources, and you can see here it's a type, and that's an HAService.py, which is a template for a high availability service. And then the properties, and I can tell it, I want this Docker image launched. I want it launched in this zone and this zone. And so I can configure all of that within my YAML file. And then principles. So we've got layered deployments is one of the principles here. So rather than just one giant file, we don't want to make it difficult. We want to be able to use those templates. We want to split it up into different pieces like network, front end, back end, using helper functions. Using Python gives you a lot of flexibility and a lot of power behind these templates. So the Jinja templates are great for templating. Python actually gives you functions if you need to do additional replacements or put a little bit of switch logic in there. The importance of the schema file, extremely important to define that template properly. Inputs, outputs, documentation is extremely helpful to share and reuse because you want to do this throughout your organization. You want to make it a culture. Switch to Python now. I mentioned about Jinja, but Python gives you a lot of different things. Real code with configs, writing real code, using that Python to actually write code as a part of this and to be able to test it and to be able to verify it. And something Deployment Manager does give you is being able to preview before update. As you go through it, you can create your deployments, but not actually deploy them or push them to a staging environment and see how things are going to work and make sure they're the way you want them. So I know a lot of you are thinking, all right, I already built out or had my team learn CloudFormation or ARM templates over in Azure. What can I do to not have to learn a new product? And that's where Terraform comes in. As a part of this, we do support Terraform. It is an alternative to Cloud Deployment Manager. So Deployment Manager is great if you are 100% GCP, and I would 100% recommend it. If you're working in multiple clouds and your team is already using Terraform or other Hashicorp products, such as Vault, Terraform is probably something you want to look at. It is open source. It does work with GCP. We do build most of the Terraform providers for GCP. So it's not just community provided. It's for provisioning infrastructure, not configuring it. So it's not a configuration manager. It is infrastructure automation. And it does support multiple clouds. That comes with a caveat. So think about it. It's not just a write once, run anywhere. Nothing is, unfortunately. We all want that single pane of glass. We all want the single provider to build and to be able to push out infrastructure to every cloud. It doesn't happen. There isn't that. Every provider is going to be a little bit different in how you do things, but it does help that you get to learn one language and one scripting language. We'll use the term language for HCL. And your team can be trained up to understand AWS, to understand Azure, to understand GCP. And then shareability. We use modules in Terraform versus templates in Deployment Manager, but it's the same concept. So an example, and I'm going to move a little bit quicker here because I do want to get into some of the CI/CD stuff. The Terraform setup, very similar to Cloud Deployment Manager, where there's a main file, there's variables, there's outputs, and that allows you to really reuse and set up variables. So you set up variables in Terraform by calling out regions, calling out providers, and then you save Terraform state. So unlike Cloud Deployment Manager, where it's part of the G-Cloud API or SDK, Terraform state gets saved somewhere. So it either has to be saved locally, which is not really recommended in the shared environment, or you can configure it to save it in a cloud storage bucket, which is preferable. So what that does is it allows you to really manage your infrastructure to determine what the changes were and to make sure that you're not drifting from that. So if somebody goes in and deletes some resources, it'll pick it up and you can make sure that you don't have drift from your current state. Modules are how you reuse. So, if you do want to reuse modules across the organization or across multiple organizations, you can parameterize pieces of that and reuse those. You can publish them. There are a lot of public modules out there. Terraform Principles. So bringing that in, very similar to what we saw with Deployment Manager, planning is really where the key is. You can run Terraform Plan to see what the changes are going to be to your infrastructure. You want to be able to take that and apply that, have change control about it, and also be able to roll it back. And that's one of the biggest thing about using these tools. Cloud Foundation Toolkit, and I'll briefly touch on this. CFT is something that we provide at Google. CFT is a mixture of Terraform and Deployment Manager. It is basically how you can get started using GCP. There are a ton of modules and templates available for reuse that show samples and examples on how to get started and how to move forward and use those things to set up common practices, how to set up a VPC, how to set up VPC sharing, how to set up Cloud SQL, and putting those things together. So it's a way to modularize and put everything together to actually get things started. And this is a start, and I apologize, this slide's a little bit out of date. You see the little dots on what is available where. Most of those are available in both right now. But when you pull down the Cloud Foundation Toolkit, there's also a pipeline generator there that will run these things and will actually show you a pipeline to test between different environments and to run these things outside of the general calling TF apply. And that's it for infrastructure automation. Continuous integration and continuous delivery. So CI/CD, question is why CI/CD? And if anybody didn't catch from the beginning and when we talked about the automation, repeatability, and reliability, the infrastructure automation does that in its code. Infrastructure is code. Well, CI/CD is not just for software, it's also for infrastructure as code. But from CI/CD perspective, why is that it helps overcome agile transformation challenges. It brings together all of the pieces and helps organizations move quickly. I hate to use the term shift left. It's, I think, overused and one of those cliches like DevOps at this point. But it really gives that quick feedback to your development teams. It makes sure that everybody can integrate. It makes sure that tests are automated. It makes sure that we can move forward in an automated fashion without having to wait on people to test, without having to wait on people to approve. We can basically code the attestation into the tools. A typical CI/CD pipeline would be something like this, which is static analysis, which is checking out the code on a push event from Git, GitHub, Bitbucket, whatever it might be, compiling, running style checks, making sure there's no security flaws or standard things in there in the code. It's optional, but it's helpful. Pre-deployment would be running unit tests, as well as any other tests that don't require deployment. It could be technology specific, depending on what it is. It could be a Maven app, it could be a .NET app, it could be a Node app, and it's building it. And then determining, how do we deploy this thing to QA and pushing it along. If it has already passed those other two steps, pushing it along to QA, building a container, deploying the code, creating a package, making sure that we're not going to build it every time we deploy it, making sure that we built it and we've stored it somewhere. We've stored the binaries, we've stored the container, and then we can just pull that version next time we need to. And then post-deployment, running all the tests that require deployment. So when I say post-deployment, that doesn't mean post-deployment to production. That means post-deployment into an environment that we can actually run integration tests between applications. So when we start talking about APIs and changing a monolithic application into microservices, that we can move things along and actually test those things together, that we can run load tests. And your result is something that's ready to be tested and built. Take CI/CD or CI the next step, and that's continuous delivery. And that is saying, okay, so all of those tests have passed. We've already done all of that. Now we need to deploy it to staging and validate that it is ready for production. So how do we determine that? We have additional tests in staging. We have smoke tests. We have maybe some human eyes that look at it to say, okay, well, this is good. Somebody that looks at a report. Hopefully neither of those are the case in your organization. Hopefully it is 100% automated. There are tools that can help with that. There are tools that can look at metrics and determine that we're ready to go. And then the next step is deploying to production. And how do we deploy it to production in an automated manner? How do we make sure that we are not going to break it, that we're not going to take down the world, that we're not impacting every user at once, that we are able to roll it back, that we're ready to turn off the new features. And those would be canary, blue-green, other deployment strategies, and I'll cover those in a little bit. And this is just a typical release process, as part of CI, it's unit tests get run, code gets checked in code repo, gets built, gets pushed to a container repo. Nightly, you might be running exploratory tests, integration tests run, and then you deploy it to production in multiple environments. This gets features out to your users quickly and allows you to deliver value to the organization. A couple deployment techniques are blue-green deployments. So for anybody familiar with that, it's basically I'm standing up a whole new set of infrastructure and then I'm flipping the switch. Toggles and dark launches are on features. So I may have A/B testing along with new code going in, so that new code may not be visible to anybody, and I may be flipping configuration flags to do that. A lot of times that's done via either any configuration system outside of the code, so you're not actually going in and making changes on the application or making changes within the app. It could be in a database somewhere, it could be on a configuration server somewhere, but it's a way to gradually release things out to your users. Rolling out updates, where deployment of new code can occur without the need of any user impacting infrastructure. So that is gradually flipping how many applications or how many servers are running the code, and new code versus old code, and rolling in the new ones and rolling out the old ones. Canary deployments, and they're very similar to rolling updates, but canary deployments would say I'm going to release to a subset of my users. That subset could be a certain geolocation, or it could be any users with this type of account. And having that small switch and then gradually ramping up another subset and more and more and more. And really the most important thing is being able to roll back. If you can't roll forward, being able to roll back, which is really important because you want that to happen quickly and you want it to happen without impact. And so this is just another little graphic of the continuous delivery train. The monitor at the end you see there, and you truly want that monitoring. You want that 100% of the time, because that's what feeds back to your source code at the beginning. And that's what feeds back to your developers, and that's what tells you, hey, I need to roll back, or I can roll forward, or I can increase the velocity of the users getting my new feature. Here's a quote from Kelsey Hightower. If anyone doesn't know, Kelsey is kind of like the, I don't know if I would say the world's expert, but the Kubernetes guy. And his quote is, there is no single continuous integration and delivery setup that will work for everyone. You're essentially trying to automate your company's culture using bash scripts. So that's really important. I've worked in several really large organizations that have tried to take the recipe from another organization and failed miserably. So the goal is to make sure that you are not just trying to fit everybody into the same box, that you're working with your users, that you are actually implementing with agility, that you are talking to your users, that you're making sure that everything works together and that it fits the culture. We do want to change the culture, but we don't necessarily want to change the culture in a bad way. And we don't want people fighting the entire time. People are going to embrace it. but it may take a little while, and then everybody doesn't embrace it at the same time. And here's a link of tools, and this just shows you kind of our Google CI/CD pipeline, the tools we have. So CSRs are code repositories, GCB is our Google Cloud Build, GCR GCS is our container registry and cloud storage, Google Cloud Build again, and Spinnaker, and I'll cover Spinnaker in a little bit, for our deployments, and then Stacker Driver for our monitoring or Google Cloud monitoring. But you'll notice there's a lot of tools below these. Everything's interchangeable. There is no one size fits all. There is no, we have to use CSR. We can use GitHub. We can use Bitbucket. We have to use Cloud Build. We can use Jenkins. We can use Travis, TeamCity, whatever it might be, and down the line. There is no one size fits all. A lot of organizations have certain tools that have grown up in the legacy world, and it's going to happen, and things need to fit together well. The good thing with Google is most of our tools are open source. Some of the managed ones may not be, but they work with other open source tools. So we try to be as agnostic as possible as we go through this. As I think you heard earlier in the presentation, we do focus on open source a lot, and the goal isn't to lock you into the platform. The goal is to provide you better tools and the best tools to make you want to use the platform. Have that portability if you need it, and we like to keep you because you want to stay. So then we start getting into Cloud Build. So this is a tool we provide. As you may be able to see by my water bottle, I've been a Jenkins fan for a really long time. I came to Google, I started using Cloud Build. Big fan. It's super easy, it's fully managed. It is manifest-based deployments. And I'll take you through a little bit of this. But basically, you set up Cloud Build triggers, which will trigger on Git updates, Bitbucket update, a tag, a release version, a commit, whatever it might be, certain branches, and then goes through a process that you set up for how you want to actually configure that. And it could be just your testing from a feature branch. It could be the merging into a master branch. There is a very cool Google Cloud Build tutorial and code lab on the Cloud Build site, which will actually take you through a CD tutorial, and it'll take you through all the steps. And really cool to build out Kubernetes and to apply manifests and actually build manifests on the fly. Here's just an example of what Cloud Build is set up. It is super simple. You create steps within your manifest file. Your manifest file lives with your container or with your code. So everybody gets to manage their own. And that goes into the DevOps concept of teams being autonomous. You don't want somebody else to have to create your builds. You don't want somebody else to have to build your code. You want to manage it. You want to be responsible for every aspect of that. So within your steps, you just say, this is the builder I want to use, which is the G Cloud Builder. And then my arguments to that are app deploy. And that's really all I need for a deployment to App Engine. It's that simple. There can be multiple steps. We can run steps in parallel. We can, access our secrets manager, access key store to inject secrets and to do different things. But it is super simple. You basically bring your own container. It is all Docker based, so you can use our current providers that we have. And I'm speeding up a little bit here because it looks like I'm running a little low on time. But yeah, and so here is another example of our cloud steps. You can set timeouts. You can set logs buckets to push your logs to, different build options, put substitutions in there so it can be, say, trigger on different branches and different steps based on different branches. And then setting image names for publishing your images to the container registry. And here's another example of how it's set up, and it's as simple as, I have a shell script with what I'm actually deploying, a Docker file that says from Alpine, and then my Cloud Build that says build this image and publish it. Within the browser, you get to see all the stats from the builds. You see what has passed, what has failed. You see your Git tags. and your hashes, and depending on how you do it, and trace you all the way back and report back to Git. You can configure it to work with Slack for notifications. You can integrate Google's Cloud Key Management Service, KMS. So if you have encrypted data, you need to push out encryption keys. You've got secrets you need injected at runtime or build time. You have the option to do all of that without exposing things to the world. Putting it all together, and this is just kind of a, Ron has these slides, so you can distribute them later. But it just shows you the builder images go into the containers, and there is a shared workspace as part of the build process. And the output goes to GCR or wherever else it might be that you're publishing your application. Here's an example, just of built-in builder images. So these are the ones that we actually maintain, that we provide, that we support. So you've got for basal builds, Git, Glide, Go, Maven, Kubernetes, if you just want a generic kubectl container to be able to run things, NPM, wget for just different tools and different things you're doing. But then there's community provided, and the list is actually much larger than this right now. So there's providers for Terraform, there's providers for F#, for .NET, for other languages. There are a ton of things out there, and pretty much anything you want to do is available. You can run tests in these containers, you can do pretty much any of that stuff. Really, it's any Docker image. So you can just say, pull my latest version of Ubuntu as a part of my build set. I don't know if you want to do that, because you may want something that already has your dependencies on it, but you can do that, and it's available to you. And then Spinnaker. And this is about my last topic here, so I'll just run through this real quick. Spinnaker is an open source multi-cloud continuous delivery platform. It's basically used to deliver infrastructure at scale. It can be used for Kubernetes, which I highly recommend. It can also be used to deploy VMs. So it allows you to push out immutable infrastructure, integrates with tools like Packer if you want to create VMs. So anybody coming from, say, an AWS world is very familiar with building AMIs. It's a similar concept. It works just like on that. It will build a container for you or build a VM for you, and it'll push it out. It will run tests. It will determine that we need to now deploy it as a canary. It will templatize it. It'll run additional tests. It'll ask for manual approvals. It will do monitoring and determine that, yes, we can move forward because monitoring is correct. And it integrates with a ton of different software. So it's not Google specific. It is open source. A lot of different triggers depending on what you're using for your build system, your CI system, different providers, different monitoring tools. So it integrates with just about everything in the CI/CD space to move things forward. And then continuously delivering immutable infrastructure, whether it's containers, whether it's VMs, whatever it might be. And here's just how it works with load balancers and how it actually configures things, and workflow as a part of this, how it tears down. It can tear down your canary environments. You can put weights in there. You can destroy the old production after a certain amount of time to move forward and to release the production. An example of pipelines. So it does show the pipelines. It has a nice visual aspect to it where people can go in and see how things are going. You always know what version is running in production, which is the most important thing there. And just examples of different providers, different operations, different things we can do there. And safe deployments. So that's your execution window. So say, okay, I've got blackout windows. I don't want to deploy it during a certain time for this application. I can make sure I do that. Manual judgments for organizations that still say I need to have somebody click a button to approve. That's available to you. It is fully auditable. I have integrated this with ServiceNow. So it is possible to do that, to key off of something else for that as well. Manual rollbacks. You can roll back manually, you can roll back automatically, and then automated rollbacks. So any deployment that may have failed, it can do that for And then serverless. And I'm not going to touch on this really other than mentioning the things because we've already talked about that. Cloud Functions, App Engine, Cloud Run are three of our serverless offerings. It's really the whole point is to focus on development, to focus on releasing features and getting new things out the door versus managing infrastructure. And that's about it. So wrapping up, quote from the beginning here, DevOps is, and here is, if anybody has been out to our DevOps site, the DORA report from 2019, here are some stats on that.
Put my video, sometimes the video can screw it up.
What's that?
Nothing. Oh, I'm all good. Sorry. I'm just waiting on you. Sorry about that.
Okay. The DORA site, or cloud.google.com/DevOps, just shows the state of DevOps report for last year. DevOps 208 times more with frequent code deployments, change failure rate of 7 times lower, time to recover from incidents using DevOps models 2,600 times faster. It's pretty incredible. And then lead time from commit to deploy 106 times faster without having to go through different stages and wait periods as part of the SDLC. But it does take work. We don't have to do it all at once. And if we do try to boil the ocean, if we do try, we will likely fail. So it is the iterative approach. It is taking it small, building a vision, making sure that you're not trying to apply it to everybody, to make sure that you know what you're after. Creating that change catalyst. So there may be a group or it may be a spattering of people from different groups to come together to all kind of come with a certain evangelical mindset to bring it to the rest of the organization. Starting small, piloting, making sure that you've got a couple applications that you know will be successful, that you can kind of push through and show the success to the rest of the organization. And having business buy-in. Every time I've done this, I've had to do it. The only way it's been successful is with leadership buy-in. Actually, them understanding that it's going to go slow before it goes fast. And then accelerating, just this being the new norm and really being able to do that. And that's it. Any questions? I do have a question up here from Robert Turner about Sec DevOps within GCP environments. It's a whole can of worms, Robert. It is, between the tools we have, we do have monitoring tools, things like Stackdriver, Cloud Monitoring, that will pull up security. We've got our Cloud Security Center. We've got tools like Forseti, which is an open source security tool that applies policy across the board, that can be used as part of all of our deployments, integrated with Stackdriver and both send alerts as well as enforce policy, create webhooks when things are out of line, as well as a tool called Chronicle, which is a recent acquisition of Google's that is, something it's similar to a SIEM, but it's, they like to call themselves, this is what a SIEM would be if a SIEM was created today. So it's truly a security-based analytics platform. So something to check out on the Sec DevOps side. That's it.